I was like, oh, I don't have to ask my mom or like message her.
Oh, I do have it scheduled for Friday. Then that's what it is. Yeah, Friday's the test. My apologies.
Wait, there's on Friday? Oh, yeah. I know, next time I'm going to Clarkson. I know.
All right. I want to talk about the test a little bit here today, okay? And then I have some practice stuff for us to work on this period. And that'll be that, okay? So if you look on your OneNote, in the content library, there's a tab at the end that says Test 2 Info. So I have here a description of kind of what to expect for the test. So I have 14 total questions. If you look at the last page of the review, which is also in the content library here, and you look at the last page, or the last pages, oh, the last page. So you get the unit circle, that's provided for you. In general, if you look at the review for the chapter, the end of that review is going to have a list of like the formulas and stuff that I would provide for you. So here it's just the unit circle listed. There could be other things, but so the topics that you should be able to do, you should be able to convert back and forth between radians and degrees. If you're going from degrees to radians, you should also be able to give me an answer in terms of pi, not necessarily just the decimal, but you should also be able to give me an answer that's like 30, or if I say 60 degrees, you should be able to tell me that's pi over 3, right? Convert it to radians where there's a pi still in your answer as opposed to, you know, like just a decimal, like 1.07 or whatever that works out to be. Should be able to solve for arc length, radius, or central angle if I give you 2 out of the 3. So that's using that S equals R theta formula. If theta is in radians, or S equals R theta pi over 180 if it's in degrees. And then you should be able to find the values of sine, cosine, and tangent using the different definitions that we've worked with. So you should be able to do that using a right triangle. You should be able to do that if I give you 1 trig ratio, you should be able to find the other 5. Again, you can draw a triangle to do that. You should be able to, if I give you a point on the terminal side of a standard position angle, you should be able to find the trig ratios from that. If I give you 1 trig ratio in the sine of another, whether it's positive or negative, you should be able to use that point on a terminal side of a standard position angle to find the other 5 trig ratios from that. And then you should be able to use the unit circle to find trig ratios. So if I ask for cosine of 300 degrees, you should be able to use the unit circle to give me the exact value for that. Or if I ask for tangent of 11 pi over 12, you should be able to do something like that, just using the unit circle. Does everybody feel okay as the test description? So nothing crazy, right? This is all just like, you know, like really 3 topics or three big ideas, you know, like converting between radians and degrees. And you do like arc length, you know, central angle, radius, and then find values of sine, cosine, and tangent under the 3 different definitions of those things we've talked about, right? Basically all it boils down to is like 3 discrete skills. Next class you'll have an opportunity to write your note card, or your half sheet, I guess, it's really half sheet, for the test. If you want to start on that early as you're reviewing, you're welcome to do that. If you meet with a tutor and you want to start studying and have them help you work on your note card, you can do that. It does not have to be made in class, it just has to be turned in at the end of next class, right? So you can start it at home. You could start at the start of the chapter. You can have it as an ongoing thing where you're like adding or subtracting things from it as you're doing your homeworks. Any of that's fine.
So is the test next class or next week?
Friday.
It's Friday?
It's Friday.
Oh, okay. It says on my listed.
Okay. It'll on the agenda next Friday. I'll have to update that. Thank you, Lily.
Yes.
So I wrote down like some stuff that, like, if I was making a note card, since it's the first time you guys are doing it, let me help you out a little bit. There's some stuff that I wrote down that I would probably want to put on my note card. So like the conversion factor from degrees to radians or radians to degrees. Seemed like on the homework quiz that went fine. Most of us seem to have that. Know what S, R, and theta represent with that formula. On the homework quiz, that didn't seem like all of us had what those different letters meant. I had a little trouble out there. Then I'd want to make sure I have my 3 different definitions for sine, cosine, and tangent. So I have SOHCAHTOA. If I don't have that memorized on what those things mean or how to spell it, no card it goes. The point on the terminal side of a standard position angle definition. Again, I'd write it down. Along with the fact that r squared is x squared plus y squared. The unit circle definition, so same idea, just gonna write it down. The all silly turtles crawl that helps me tell which trig function is positive in which quadrant, write it down. Now, is that all I would write if I were you? No, man, I'd include some example problems of like how to do stuff or any other miscellaneous things that you found that were hard while you're doing homeworks. Or if we're talking about and I mentioned something, you're like, that's a good thing for me to put down. You know, like this is just like a starting point. But like if you don't write this definition down for like the point on the terminal side of a standard position angle, if you don't have it memorized, it's not going to be there for you. So like, you got to do one or the other. Either put it on your note card or you got to memorize it. Okay? And what happens if you're absent on the test day? You don't get the note card, right? So even if you made one, you don't get to use it. It's now forfeit. Just putting that out there for you to remind you if that helps impact your decision making at all on the day of the test. We're trying to do you a solid, right? You gotta be there on the test day for me to use that. Does that feel okay? So again, this is also where? In the OneNote, right? All these things that I write down for you, all in the OneNote. What I'm gonna pass out to you right now is your very own copy of this very wonderful unit circle that we talked about last time. So we're all going to get our own physical copy of this. Isn't that great? I'm so excited. Make sure you put your name on it. If you lose one, I'll have some extras, but not like infinitely extras. So this, the unit circle that I'm just passing out to you now, this will be a part of every like summative assessment thing that I give you. If I expect you to use this thing, I will give you a copy of it with the test or the quiz or whatever it is. You do not need to have your own on the test or quiz day. I will give you one. Cool?
Yeah.
Okay. So once you have your name on it, I would include one other thing. I would write down on this thing that like cosine equals x, sine is equal to y, and tangent is equal to y over x.
Yeah, can you repeat that, please?
Cosine is equal to x, sine is equal to y, and tangent is equal to y over x. Now eventually that'll be something that you'll have had memorized, but that is just my unit circle definitions for the big three there. Everybody feel okay so far? All right. So I want to just kind of walk through the delta math that you're going to spend the rest of today kind of working on. Very good. So the first type of problem says, given the following unit circle, rotate the green dot to approximate the angle, and then find the exact value of the function. So I'm going to take my unit circle. I'm going to look for 45 degrees on it. I see 45 degrees. It's located in quadrant 1. So I'm going to rotate my guy here. Notice as I do that, there's like 3 ticks, and then it goes straight. You see that? There's 3 ticks inside each quadrant. Which tick is 45? Is it the first tick, the second tick, or the third tick? Second one. That's right in the middle. Great. And if I go to my unit circle, if I look at sine of 45, how do I find sine on the unit circle? It's equal to, we wrote it down on our paper, y. So I'm going to look at where 45 is on my unit circle. Look at the y coordinate, which says square root 2 over 2. So that's what I'm going to type in. And then I'll hit submit. Let's do it again. Okay. Next problem says cosine of 180 degrees. Where's 180 degrees on my unit circle? Pointing straight to the left, correct? So I'll spin that little guy all the way straight pointing left. And the cosine is x, and the x coordinate at that location is -1. That's correct. Let's do another. Cosine of 330. So if I look at my sheet, 330 is the last spot before I'm back to the beginning. You see it in the 4th quadrant there. And then which coordinate am I looking at if it's cosine?
X.
X. The x coordinate there is?
Square root of 3 over 2.
Root 3 over 2. How's this feeling? Is this okay?
So easy.
So easy. That is what I love to hear. That is essentially all this thing is, right? It's just an exact value calculator. So all we need to be able to do is like use it to look values up. All right. Some more practice. So it says here we want to rotate the point to -632 degrees within 10 degrees. So see the yellow dot? I'm just going to spin that around till I'm close enough. So because it's negative, which direction should I go? Clockwise. So there's 90 180, well, I should say negative 90, negative 180, negative 270, negative 360, negative 450, negative 540, negative 720 is here. So we're at negative 540 here, right? That's what I said. And then, oh, negative 630 is like right here then, right? Okay, so go a little past it and we'll say that sounds good. And there we go. So it told us what we did. My answer was negative 631. Pretty darn good, within 10 degrees, close enough. Everybody feel good about doing this? Again, not hard, but like this is a skill that we need to be good at, right? To get these standard position angles in the correct quadrant, be able to draw them reasonably close to what they actually should look like. And again, it doesn't have to be perfect, it's an approximation, but like within 10 degrees should be totally doable. Okay, everybody good? Oh, we also have small angles, so it's the same idea. So this one is negative 170. So again, it's negative, it's this direction. And it's like, you know, a little less than straight the other way. And it says, yep, that was good enough. What I wrote negative 168. So within 2 degrees. Pretty decent. Okay. Next one is it's going to give us some signs of the trig functions. We have to figure out the quadrant. What am I using to do this?
The table.
Yeah, the all silly turtles crawl, right? The XY axis where we wrote it all down. That's all I'm using. So cotangent is negative, that's the same as tangent negative. Cosecant positive is the same as sine positive. So what quadrant is tangent negative but sine positive? That would be 2. Remember, sine is the y-coordinate. Where is the y-coordinate positive? Well, 1 or 2. Tangent is y over x. Which quadrant is only one of them negative between 1 and 2? It's quadrant 2. Let's try that again. Who's got the answer to this one? It is 2 again. That's correct. Yeah, it was the same question, except they gave us sine positive instead of cosecant positive, but they're telling us the same thing. Let's try it again.
Is it the third one?
Is it what?
The third quadrant?
The third quadrant is incorrect. So quadrant 1 is correct. So secant is going to be the same as cosine. Cosine is x. So what quadrants is x positive? 1 and 4.
Yeah.
Cotangent is the same as tangent. Tangent positive means that both x and y are the same sign. Quadrant 4, x positive but y is negative. Quadrant 1, both positive. That's the one I want. Does that make sense on how I did that? Again, you can look at your all silly turtles crawl picture too. Like that is okay. If you put it on your note card, you'd have that for the test. So, next question is a coterminal angle question. It asks us to find the angle coterminal to negative 600, but it says our answer needs to be between 0 and 360. So if I add 360 once, I get negative 240. Right? That's not enough. What am I going to do? Add it again. And I get 120. Is that between 0 and 360? Yup. So I'm done. I just type it in.
Alright, equilibrium.
Okay. 590. Want an angle coterminal to it between 0 and 360. What do I do?
Remember, unit 1.
Perfect. How'd you know to minus 360 instead of add?
Because it has to be between 0 and 360.
And 590 is already too big, right? So we have to subtract this time. Does everybody catch that? 590 minus 360 is 230. Boom, done. Is everybody okay on this? Pretty straightforward, right? Okay. This is the same as the first one with one added wrinkle. What is the added wrinkle here? If I look at this problem title and this problem title, what's the only thing that's different? I can get tangents here now in my questions also, right? Does that mean a whole lot to me? You know, still gonna kind of do it the same way. All right, sine of 0, well, it's already there, right? What's sine of 0 if I look at my unit circle? Sine is the y coordinate, which is 0. Tangent of 270. Okay, did you find 270 on your unit circle? Where's that at? Straight down, right? So we'll spin that there. Tangent is y over x. What is the y coordinate at negative 270? Negative 1. What's the x coordinate? Negative 1 over 0 is? Not 0.
Undefined.
Undefined. 0 on bottom is undefined. 0 on top is 0. So we'll say this is undefined. Feel okay doing these? Really the same thing as the first one, just we can get tangents now in the questions as well as sines and cosines. And our last question type is asking us to use our unit circle to find exact values. And it's one of these timed ones where you have 100 seconds to get 10 in a row correct. Just practicing looking these things up off the unit circle. So if I look at this, what's it look like? Tangent at 240. 240, y over x is this guy. Tangent 270, we just did it. Cosine 150. 150 is 1/2 over negative root 3 over 2. So that's going to be that one. Oh my goodness, I thought it went anyways. It was over 3 over 2. That was rude. Anyway, you get the idea. I can't believe I messed that up. I'm embarrassed. All right. So you guys feel okay as to what to do on these delta maths? We ran through and did some examples. Get your tablet out right now. Start on the delta maths. You need to be able to use the unit circle effectively. Most of this practice is like unit circle-ish related stuff. These are important sub-skills that we're working on. They will come into play immediately in chapter 3. We're heading next.
I'm just gonna keep doing my guessing game.
Yeah, just do your guesses.
Okay.
That's one of the, yeah.
I won't be here.
That's 7 Friday.
Can I?
So what's the 16 plus 5?
Yes, either should be okay.
I want to go to Lumen, so we'll see.
Because I've never had
Yeah.
something
Let me know
so
which one you wanna do. Or the
I
next day after.
Plus another
No,
one.
I don't have.
I'll leave it in,
That's 6:30. So go
at your point in time.
Okay.
I know some hard and songs.
Make it as easy as I can, right?
Yeah, like,
Where would my 150?
Every other one word, right? I don't know how to do it.
I would like to know.
So,